Okay, well, how was everybody's weekend? Good, good, good. Everybody knows we got a 3-day weekend coming up this weekend. Y'all got to come to school on Monday. It's a professional development day for us. So, okay, okay. Wow, that was nice high five. Okay. So, while you folks are pulling out your notes, if you haven't already done so, a couple of housekeeping items. So, this coming Friday, that would be September 26th, at 8:05 in the morning, that's the deadline. If anybody is wanting to retake the graphing other trig functions from last Thursday, you do have to have the assignment turned in before you retake. Okay, so please, I'll be looking at that if that applies to anybody. On Friday, I passed out the sinusoidal homework packet for the lesson that we're currently on. That's going to be due on Wednesday. If you haven't started looking at that, please start tonight, because on Thursday, your quiz is a bunch of these word problems. Okay, so please practice those. Be looking ahead. Okay. In fact, who was not here on Friday? Anybody? Fantastic. Okay. And then I want this, you go, make sure you're aware of this. Coming up next Thursday, that's going to be October 2nd. That's going to be the second exam of the 9 weeks, because we're actually quickly, within 3 weeks, going to be done with the first 9 weeks. But this one here is going to cover graphing all 6 of your trig functions. It's going to have the sinusoidal word problems on there. So on Friday, I will be passing out the 3x5 note cards. Whatever you would like to write on that, you could use during the exam. That's completely fine. Okay, so questions about anything coming up? Well, sounds fantastic. All right. Let's see here. On Friday, we got to number 7, where we went ahead and found the characteristics of that function. So now we're on number 8. Okay. Cheryl opened a bakery and found that her monthly profit followed an up and down pattern during the first year. She discovered that her profit could be modeled by P of t equals 2t minus 7 sine of pi over 3t. So the good news is we don't have to write the equation this time. Now, P is measured in hundreds of dollars. That's the profit. And T was measured in months after January 1st. So use a graphing utility to find the following. Okay, well, the first thing is we need to go ahead and plug this in the calculator. So let's get our calculators ready. All right, I'm going to come on over here. Okay, so I'm going to go to graph. Now, because we're using a radian measure, you want to make sure your calculator is in radians. Yes, needs to be in radian mode. Now, I'm going to go to my scratch pad, but this is going to work just fine if you go to a document. Again, just make sure it's in radians. So this one is 2t minus, so I got to change that to x because we're in the calculator, 7 times the sine. Remember, the trig button is right over here on the left, right next to 7. Okay. We want pi over 3, so I'm going to hit Control Divide. I like to use this button down here at the bottom left, which has pi on it. There's a lot of very useful characters in here, but pi over 3x, and I believe that is correct. 2x minus 7 sine of pi over 3x. Okay, let's go ahead and graph this thing. All right, so we should have a graph that looks like this. Now, we're talking about profit in time, so let's say we're going to go ahead and limit ourselves to the first quadrant, okay, because we're talking about the real world. Where on this curve would she start to earn a profit? Any ideas? On the right? Like on the right of what? Like, what do you mean? The y-axis? Okay, right. So we're talking about after it crosses the x-axis to the right of y. Yes. So down here below, this would tell me that while she may be making a profit, she's not covering her. Well, let me rephrase that. Profit is the money you have remaining after you've covered your production costs. So up until this point, it looks to me like she's probably not covering her production costs. So we're talking about her revenue. I want to make sure I use the correct terminology. But yes, at this point where it crosses the x-axis, this is where she starts to get a positive profit. So I need to know what this value is right here. Okay, so we're going to go through a set of keystrokes similar to what we did last week. I'm going to go ahead and hit menu. Okay, so we want to analyze the graph, but this time we're not looking for an intersection. I want the 0. Okay, because remember, this is where it's crossing the x-axis. So that's an x-intercept, a solution, a root, a lot of vocabulary we could use there. So let me get out of that one more time, go through. So it was menu, analyze graph. We want that 0. Now, just like before, it's going to give me this vertical line. And let's say I want this location. Remember, lower bound, I want that vertical line to the left of what it is I'm trying to find. And you can use your touchpad to go ahead and move this around. I'm going to push enter, lock it in place. When it says upper bound, that means the right side. So I'm going to go ahead and sweep this across. So it looks like 2.31 months into the year is when she breaks even and she starts earning a profit after that. Okay, so what month is that? It's not February. It would be March. Because see, look at how we're doing this. You don't have a full month until you reach the end of the month, right? So the way we're reading this, we've gone through the first 2 months, and this decimal, we're now a portion of the way into the next month. So I'd say we're about a third of the way into March. So it's going to be March when that happens. Okay. This is where she breaks even and where the profit begins to become positive. Okay. Now, for part B, it says, in what month did her shop make its greatest profit in that first year? And what was her profit? Okay. So let's come on back over here. So this is where we're going to go ahead and start changing the window. So I'm going to go to menu. I'm going to go to window zoom. Now, remember I said last week, if you prefer to zoom out or you want to try to use zoom fit, if you feel that works for you, fantastic. I got in the habit a very long time ago of making the changes myself. So now we're doing this on a year basis. So horizontally, why don't we say we're going between 0 and 12? Okay. Now we're also only interested in her earning a profit. So maybe vertically, let's go ahead and start with 0. Okay. So if I go ahead and push enter right now, here's what I got. So I've got a width of 0 to 12. We're starting at a Y minimum of 0. I haven't touched the Y maximum yet. Okay. Here's what I got. So I'm looking for the largest profit before it goes over here to the right side of my screen. That's the end of the year because remember, we're only going to 12 months. Okay. So now we only have to decide how high we're going to put my screen. Okay. So give me a value. Let's see if it'll work. 20. So let's go for 20. I'm going to push enter. Okay. Not quite. We're getting close. But it hasn't, I haven't seen it curve and go through the right side of my screen yet. So we got to go a little higher. Okay, let's go, what do you think? 30. Let's go 30 first, and then if that doesn't work, we'll go 50. There we go. We don't have to go any higher. So we're looking for the maximum profit, so I'm looking for the maximum of the function. Now, some people out there may be thinking, well, that is the absolute maximum. You know, we have relative maximums here. We're going to be talking about that, you know, later in the year. For right now, this is what we want. The maximum profit and what month did it happen. Everybody's with me? Got it? So let's go through the keystrokes. I'm going to come over here to menu. We're going to analyze the graph. So I don't want intersection, I don't want 0, but I do want the maximum. So we want to make sure to choose the correct command. Okay, lower bound. So I'm going to put this vertical line to the left of what I'm looking for. Upper bound, we're going to sweep it to the right. This will let me grab it. There we go. So it looks like 10.76 months into the year, that's when she got her largest profit, according to this function. So what month are we in? We're in November. Because, see, we've gone through the first 10 full months, and we're almost 3/4, well, actually a little more than 3/4 of the way into the next month. So we're in November. How were the profits measured? In hundreds of dollars. So this 28.26, we'd say that profit is what? 2,826. We multiply that by 100. Okay, so if I come on over here, that's why I've got this. In November, Cheryl's Bakery had a profit of about $2,826. Okay, November, because we had the 10.76, and then the profit was 28.26, which we're measuring in 100s. Well, I mean, especially, what is it that it's the vast majority of businesses within the first 5 years are going to fail? It's very, very, very difficult. Well, I mean, you raise your prices too much, then people don't come to your store. I mean, inflation nowadays, look, shoot, it's bad. Who's to say that she didn't do that? And then maybe those folks are just going through the economy the same way we are. Just they're trying to get like the basic stuff. They can't afford the sweet treats. I think we're reading into this problem a little more than we need to. Okay, are there any questions about number 8? You know what? No matter what, I think Cheryl will rise to the occasion. Bakery, rise. Oh, probably don't want to talk about politics. Yeah. Let's take a look at number 9. Here we go. Okay, hurricanes are categorized using the Saffir-Simpson hurricane scale. The table below represents the number of major hurricanes in the Atlantic Basin that are rated as major storms of category 3, 4, or 5 for each decade from 1921 to 20. So part A, use the graphing utility, so we're talking about a calculator, or Inspires, to create a scatter plot of the data for t equals 1 to t equals 10 for the decades shown in the table below. So when you hear this word scatter plot, a lot of you might think back to graphs that look like this. You've got just a bunch of points in space. Okay, you might remember the words correlation, positive, negative, weak, strong. But I want you to go ahead and realize that any graph that you've ever created over your academic career, if it's a linear function, quadratic function, rational, etc., those are all versions of scatter plots. There's still a comparison between two quantities. Typically we just call them x and y, but they just have specific relationships. Is everybody okay with that? So all the graphs that you've looked at up to this point, they are scatter plots. Okay, so according to this data, like in 1921 to 1930, there were 5 hurricanes. The next decade, 31 to 40, had 8, and so on, all the way up to 2020. Okay. So what we want to go ahead and do is take this data and we're going to put it in the calculator. So that's why I have this sheet typed up for you. So in case you ever forget how we talked about this, the keystrokes, you've got this in your notes. So one thing about this, go ahead and keep up with me and do exactly as I'm doing as we input the data into the calculator, because if you decide to work ahead and you make a mistake, I may not be able to figure out what you did or exactly where you're at. So let's all go ahead and keep on the same page. So how do I input data into the calculator? Well, I'm glad you asked. Okay, I'm going to go back to my home screen here. Now, if there's already something in your calculator, if you're in your scratch pad, I'm just going to hit document B. Let's go ahead and get rid of that. Okay. Now, if you're using a document, I'll go ahead and show you how to do that in just a second. Okay, Control W, I reminded you last week. So first thing we need to do is new. So we're going to push 1 or we're going to choose new. This is the list that should come up. So if a person used your calculator before you and they just left a problem in there, it's going to pop up and ask, do you want to save this? Just click no, and it'll go ahead and get you right here to where we need to be. Okay, so what we need is lists and spreadsheets. As soon as I click that, it's going to take me to my spreadsheet. Okay, does everybody see this on your screen? Okay. Now, before we start inputting the data, we've got to tell the data calculator what the data represents. So here we're talking about decades and we're talking about the number of hurricanes. You're more than welcome to actually type in the title. This is the part where I get a little lazy. I'm just going to go ahead and type in X and Y. Makes it super fast, and I know what X and Y represent. Okay. Now, very, very, very important. You see this row here right next to the equal sign? We will never put anything in this row. We are always, always going to absolutely leave this blank. How many people are familiar with Excel spreadsheets? Okay, so some folks probably already know that if you want to go ahead and perform a calculation or an operation involving multiple cells, well, you can type in formulas, and those formulas are typically going to start with the equal sign. That's what we would be doing here, but that does not have anything to do with what our purpose is. So we are going to skip it. Okay. So this first column here is just going to be the number of the decades. Like, for example, 1921 to 1930, that's the first decade. Okay. Now, you always want to arrow out of your cell or push enter once you've input the number. So now we're going to put this first column all the way to 10. So 2, 3, 4, 5, 6, 7, 8, 9 to 10. And this is the number one mistake that I see students making in the beginning until we get accustomed to this. I can see that 10 right there, but I'm still inside the cell. So if I were to go ahead and try to do something with this data, the calculator doesn't see that as a 10. In fact, it doesn't see it as anything. It's still a blank cell. So you always want to make sure to get out of the cell before you do anything. Okay. Now, this set only is 10, so it can be pretty easy to scroll back up. But if you're working with a large set of data, here's a little shortcut. If you hit Control 7, it'll automatically jump you right back to the top. Okay. And now we want to put in the number of hurricanes. So in that first decade, there were 5. In the second decade, there were 8. And then we're just going to go ahead and fill this all the way in. So 10, 8, 6, 4, 5, 5, 11, and finally 9. 9 hurricanes in the final decade. Okay. So I've got my data in, and this is a crucial step in the entire process. Everything that we do forward is going to depend on what you've input. So it's always a good idea, take a few seconds, scroll back over your data, make sure it's correct. Okay, that'll save you a lot of trouble and headache down the road. Okay, but does anybody need help plugging in their numbers? The 6th decade, that was 4. Okay, then 5, 5, 11, and 9. Okay, all right. Anybody else? Okay, once you got your data in, this is where it becomes easy. So I'm going to go back to my home screen. Okay. Now, we're going to want to choose one of these icons at the very bottom of our screen here. We're going to come all the way down here, choose the one that looks like a bar graph. This is data and statistics. Okay, now as soon as you click this, hold on just one second. So I'm going to push enter. Okay, there we go. See, we haven't told the calculator yet how to organize the information, so we don't have our axes set up. This is the one and only time where our screens are going to look different. Okay, without those axes, basically the calculator takes those values and just throws them on your screen. Okay, now you could go ahead and use your touchpad. You could hover the mouse over these areas where it says click to add the variable. I like to go ahead and use tab. If you push tab, you'll notice the 2 column headings that we typed in, they're going to pop up. Always take care of the first column, the horizontal axis first. So because X is highlighted, I'm going to push enter. And see, it's lining up those 10 decades. Now I'm going to hit tab again. And this time I'm going to choose Y. It's going to go ahead and associate the Y value, the second column, with each of these X's. And there's my scatter plot. And see, it's nowhere near perfect, but you can kind of see that if I started here, I do kind of have a sinusoidal curve that I could put through here. Okay. So is there anybody's screen that doesn't look like this? Let's do this. Let's delete that. Okay. That looks correct. Okay, so let's go to home. There we go. Yeah. Okay. Anybody else? Okay. So now the only thing I have left for the calculator to do is go ahead and draw the curve and then go ahead and give me the equation. Okay, so here are the keystrokes. Here's how I'm going to do that. I'm going to go to menu. So we're going to want to analyze. Regression. So you might remember back in algebra when you were looking at scatter plots, you tried to use a trend line or a line of best fit. Do those sound familiar? Okay. We would refer to them as a regression line. Here we're going to call it a regression curve. Okay. And then once you choose regression, then you choose sinusoidal. Okay. So let me run through that again. You go to menu, analyze, regression, and we're going to choose sinusoidal. So right there, it gives me an equation that best models the data we input. Yes. And in fact, I've already got it on my paper here. So let me go ahead and scroll down. So there we go. So 3.0627 sine of 0.9778x minus 1.4956 plus 6.6667. You know what? I had the idea to do that today, and I thought, you know what? I'm not going to do it because I hear it every day in my Algebra 2 sophomore classes. Okay, so I thought I'm not going to do that, but somebody in each of the classes so far today, 6, 7. So I thought, you know what? I'm going to do it. I'm going to do it. 6, 7. There we go. Okay, so any questions on how I got that equation? We're good. All right. So now using this equation, now we're going to answer some questions. Okay, C, what is the maximum and minimum number of storms based on your model? Okay, so be thinking of last week. Okay, I've got the values of A, B, C, and D because I have the equation, right? Okay, what two values did I use to help me find the maximum and minimum? A and D, yes. The amplitude and the midline. So remember, for that quiz coming up on Thursday, it's really going to be beneficial to remember those little shortcuts I gave you. So I can use the midline D plus the amplitude A. That'll give me the maximum. And then the midline D minus the amplitude A, that'll give me my minimum value. So with A equal to 3.0627 and D equal to 6.6667, see, I didn't do it that time. Okay. I'm going to add and subtract those two numbers, and then you can, go ahead and confirm in the calculator. I'm getting 9.7294 and 3.604, but we're talking about the number of hurricanes. Okay, so I'm going to go ahead and round these up. So I'm going to go ahead and say we have a maximum of 10 hurricanes and a minimum of 4. Okay. Right here at 2055. Okay. Questions. How are we doing? I did, yes. Some of the stuff I'm aware of, like, that's no cap, but I mean, I low-key have the vocabulary down, or at least I try to, because I like to understand what my students are saying to me. But yeah, the 6, 7 thing I did not get until I asked one of my kids, and they were like, "It's nothing. It's just being done." And I was like, "It's got to mean something." Like, they told me it came from a song. What song? Okay. Oh. Okay. So what's the hand motion? Why do people do? Why do they do that? Yeah, my sophomores do that. There you go. Okay. Very mindful. Very demure. Okay. Demure. Okay. Last question here. So part D. In what decade will the next maximum number of storms occur based on your model? Okay, so remember, like I said last week, they're not just going to come straight out and ask you for something specific. Okay, so in this here, I do need a specific characteristic to answer the question. What are we referring to? The period. That's exactly right. So if we're at one maximum, how long is it going to take to get to the next maximum? We need to know what the period is. Okay, so do we have an expression for the period? Well, oh, C over B is the phase shift. 2 pi over B. There we go. So I'm going to say 2 pi over B. Now remember, that will get me my period, and because we have the equation, I know that B is 0.9778. So I'm going to say 2 pi divided by 0.9778. Okay. So let's go ahead and input this in the calculator. and we'll go ahead and see what my period is, how many decades it's going to take before we reach the next maximum. Okay, so I'm going to go back to my scratch pad, control divide. Let's plug in 2 pi, 0.9778. Okay. And again, you can check me on this, but I'm getting 6.43 decades. Okay, so 6.43 decades is going to be my period. Okay, so that means when I come back over here, let's look at the table. Well, based on all the information that we have, it looks like I have a maximum occurring in the decade from 41 to 50. And then about 6.5 decades later, I have it again with 11 in 2001 to 2010. So what I want to do is take this 2010 and let's go ahead and add about 64 years. Where did I get 64 years from? Remember that 6.4 decades. There we go. So what is a 2010 plus 64? 2074. Oh, and I didn't write down the value here for that. What was it? 6.43? I didn't write that down. 6.43. So yeah, that'll be the year 2074. So the way they wrote their decades, this should be 2071 to 2080. Okay, how are we doing? Anybody having a hard time? Anybody lost? Okay. All right. We've got one final question. We are done with these notes. Okay. Number 10. It says the table below shows the average temperature per month for Atlanta, Georgia. Information was found at the World Climate website, and you can go ahead and look this up if you'd like. But we've got our months, and we've got the high temperature for each of those months. Part A says plot the data below, and notice that they approximate sinusoidal behavior. So, for example, January is the first month, and we had a high temperature of 51.6. So I'm going to estimate this. It looks like we're doing this in fives. So 51.6, maybe about right here. Okay. So that's what I want you to do. Take about a minute, minute and a half. Go ahead and plot those points. Okay, go ahead and get me my sinusoidal curve. Yes. Give me back. Wait a few more seconds on that. Okay, so here is what I got. Okay, so a nice smooth curve going through there. Definitely looks sinusoidal. Okay, is that looking to be about what everybody got? Okay, fantastic. All right, well, let's see what part B says. Why does it make sense that the average monthly temperatures can be modeled by a periodic function? Okay, so I know what I put, but I'd like to hear some of your ideas before I go ahead and show you. Okay, check. Yeah, so as the seasons change, the temperatures change with them. Yeah, I mean, getting real specific, I mean, the northern hemisphere of the Earth is going to be either tilted away or towards the sun. Okay. Now, I didn't get that specific in my answer. Here's what I did. I said average monthly temperatures will not vary and will repeat about the same from year to year. Temperatures are cyclic with the seasons. Okay. So in summertime, you can expect it to be hot. Wintertime, you can expect it to be cold. So average monthly temperatures will not vary and will repeat about the same from year to year. Temperatures are cyclic with the seasons. Okay. Okay. Let's see what part C wants me to do. So it says, let's model this graph with a sine function in the form of a sine of bx plus d. Use the data plot to estimate the amplitude, period, and vertical translations. Okay. Well, we can go ahead and immediately find the amplitude in the midline, A and D, if we have the maximum and the minimum. Remember, those were the shortcuts from last week. Do we have a maximum and minimum temperature? We don't? We could get it from the what? We could get it from the table. Here we go. So looking at all these temperatures, what's the highest? Okay, so let's say that 88.3, that's my maximum. And what's the lowest? January, 51.6. So let's say that's my minimum. So from our data, we do have a maximum and minimum value. Okay, so let's see here. If I come over here, so the maximum, 88.3 minus 51.6, divide by 2, and you can go ahead and confirm this in the calculator, but I got 18.35. Okay, and then if I take the 88.3 max plus the minimum 51.6, divide that by 2, I got 69.95. There we go. So right there, I've already got 2 of the 3 items I need for my equation. Oh, someone else. Okay. So now, anybody think they might know what B is? Or at least have an idea how to find it? Now remember, we know that B represents the horizontal dilation, but as a characteristic, it helps you find the what? Okay, so do we know what the period is? Ooh, not quite. How long is this going for? A year, so 12 months. That's the period before it starts to repeat again. And remember, what was that expression we used a moment ago? 2 pi over something? 2 pi over b? So 2 pi over b, I got to work backwards to find b. I know that the period is 12 because we have 12 months in the cycle. Okay. And just like we saw this, several times last week, I'll cross multiply. So 12b is equal to 2 pi. So it looks to me like b is what? Pi over 6, 1/6 pi. Okay, let's go ahead and put all this together. So y equals, A was an 18.35 times the sine of bx, so pi over 6x, and then plus d, 69.95. There we go. So this is what we came up with by hand with the data table. Okay. Questions? Now, let's do a comparison. Listen. Yeah. Do I need to divide what? Oh, because when I cross multiplied, I got the equation 12b equals 2 pi. So then I divided out my coefficient and solving for b. So we're going to do just like we did a moment ago. We're going to take that data, we're going to go ahead and input it. We're going to have the calculator come up with an equation, and then we'll be able to do a side-by-side comparison and see how well we did. Okay, so you folks are going to help me with this, because on Thursday, you are going to have to input some data into the calculator for one of your questions. Okay, so let's see here. I'm going to go document B. Okay, let's go home. Okay, what do I choose? Okay, so we got to get to the spreadsheet. So to do that, we're going to choose a new document. Okay, now remember, if something is already in there, then we're just going to say no. Then that brings up the list we want. So we want lists and spreadsheets. Okay, super important that we don't forget to put in column headings. Okay, now remember here we're talking about the month of the temperature. I'm going to get lazy. I'm just going to put in X and Y. Okay, what am I going to put in the equals row? Nothing. Avoid the equals row. Okay, do not put anything there. So now for this first column, we're talking about the months of the year. So all I got to do is count to 12. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and 12. Okay. Now you can scroll back up, but remember the shortcut was Control-7. Okay. And now we're putting in the monthly high temperatures. So for January, it was 51.6. Then 55.9 for February. I'm just going to go right down the row. 72.7, 80.1, 86.2, 88.3, 87.4, 82, 72.7, 62.6, and finally 54. Okay, so anybody need help inputting your data? Okay, where do I go from here? What's that? I'm glad. See, I wanted to see if anybody was going to catch it. See, I see that 54, but the calculator doesn't see it. If I went to my home screen and tried to continue the problem, it's going to come up and say there's a dimensional mismatch. Okay, so that means that it's not viewing a value corresponding to another one. There we go. Okay, so now I'm going to go home. Okay, which of these at the bottom do I want? Okay, the pink one here, data and statistics. Looks like a bar graph. Okay, I'm going to push enter. Remember, our screens are going to look different. This is the only time. Okay, now you can hover your mouse using the touchpad over the click to add variable. I prefer to use the tab button. Always take care of the horizontal first. Okay, so there are my months of the year, tab, and now here are the temperatures for each of those months. And there's that curve that you just plotted by hand. Okay. Bless you. Does everybody's screen look like this? Does anybody need help? Okay. So let's run through the keystrokes. I need to see the curve and the equation. What do I do? So menu. Okay. Analyze. Regression. And then we're choosing sinusoidal. Okay, so here's my equation. Okay. So I'm going to come on over here. Now remember, this is what we worked up by hand. Let's see how it compares. Let's see, our midline is a 69.95. There's a 69.596. That's not terrible. Okay. The one that we're off the most is going to be the midline, the amplitude A. 18.35 is what we got. 19.37 is what they got. 0.48 when I round it for B. If you go ahead and put pi over 6 in the calculator, it's going to come out to about a 0.52. Okay, so all in all, we did a pretty decent job of coming up with an equation by hand. Okay, but we're going to use this equation here. Okay. Any questions? How we doing? Okay. Now we are going to go ahead and skip E because we haven't talked about points of inflection yet. Does anybody know anything about concavity? It's okay. We are going to be talking about that later. That's why we're going to go ahead and skip this. So here's our last part. Explain the meaning of the maximum and minimum values in the regression model as they relate to the context of the data set. Okay? Now, it doesn't specifically ask us to find the max and the min, but let's go ahead and do it. It's good practice. Okay? Remember, I can find the maximum and minimum using the midline D and the amplitude A. Let's go ahead and use the values we have from my calculator, the one it gave. Okay, so I'm going to add or subtract these two. So 69.596 plus or minus 19.37. When you add, you get the max. When you subtract, you get the minimum. So I'm getting 88.97 and 50.23 for my high and low temperatures for the maximum and minimum. And again, according to what we had in the table, that's still really close. But you have to understand that a lot of times, pretty much all the time, especially when you're taking real world data, it's never going to be perfect. That's why we go ahead and try to choose the model that we think will work with it best, and then we analyze it and interpret the results. Okay, it will never be 100% accurate. Okay. All right. So how do these relate to the context of the data problem? You might want to tell me, or should I just show what you got? Yeah. So, like, what month would you be in? Well, it could potentially vary, especially if this was only one, city. But in this case here, I'll just go ahead and show it. In July, the maximum temperature is about 88.97 degrees Fahrenheit. In January, the minimum temperature is about 50.23 degrees Fahrenheit. Okay. So essentially, you'd expect to get the maximum temperature in summer, while you expect to get the minimum temperature in winter. Here we go. And with that, we are done with the sinusoidal applications. How many people have had the opportunity to start the assignment? Okay, so nobody's hands are going up, so please, please, please. Remember, what's on Thursday? You have a quiz that's nothing but these word problems. So please take a couple tonight, practice them. Don't wait. Okay? Go ahead and start practicing these. Do me a favor, erase everything you have on the calculator, whether it's a document or in your scratch pad. Once you've got that done, let's get the calculators back up here, and we are done for the day.